Hey folks, checking out class number 37. This is really good review for horizontal projectiles and for your quiz number 9. So class 37 opened up with just talking about what an XY chart is. Basically, you did this already. But you know that the initial velocity and final velocity in the x direction are the same because the velocity in the x direction is constant. There's no acceleration in the x direction. Okay, the time is the link between the two. It's the same for x and y. So that's why those two boxes are connected. All right. So why are the boxes for initial final velocity and the x column merged? Vi and Vf are the same because Vx is constant. This ties into the next point. What is always the acceleration in the x direction for any projectile? 0 meters per second squared. Why? Because there's no net force in the x direction. You could also say there are no forces in the x direction. Number 8 says, what is always the acceleration, AY, in the y direction for any projectile? It is always going to be 9.8 meters per second squared. It could be negative sometimes, but it's always going to be 9.8 meters per second squared. Because the net force in the y direction, the only force in the y direction is the force of gravity. That's why AY is equal to little g. All right, so this is just some practice using an XY chart. This is a question we saw last class. So Mia's pencil rolls off her 1 meter desk with a velocity of 0.7 meters per second. So here's an image of what's going on. So my Vx value is 0.7 meters per second. That's why I plug it into the initial and final velocity for the x column. The height of the desk is 1 meter. That's a y distance, right? You see how it's a vertical distance, so that goes into the distance in the y column. I also know that for any horizontal projectile, V initial y is going to be equal to 0 meters per second. Because think about it, as it's rolling along the desk, all of its velocity is in the x direction. There is no velocity up and down until it leaves the desk. Once it leaves the desk, then it starts to speed up in the y direction, but initially it is 0. I can also always fill in AX is 0 and AY is 9.8 meters per second squared. So the first thing was to find how long it is in the air for. So I can try to use the x direction. It won't work. You don't have enough information in the x direction, but in the y, I do have enough information. I know the initial velocity, I know the acceleration, and I know the distance. So I can use d equals VIT plus 1/2 AT squared, and I get a time of 0.45 seconds. So I fill it in there. Next, I need to find my horizontal distance. So I can use the same exact equation, but use my horizontal values. My initial x velocity is 0.7. Okay, it's my initial and my final. My time is 0.45, and my acceleration is 0 in the x direction, so I can get 0.315 meters. Let me just throw that in onto the line here, 0.315 meters. You could also use this equation, V equals d over t. That's the only equation you can use in the x direction. So you have 0.7 equals d over t, and you get 0.315. You can never use this equation in the y direction. Don't try it, because that equation assumes that the acceleration is 0. All right, so looking at this one, again, this is from last class, so I'm going to go over this one specifically quickly. You got a marble, it's rolling off the table at 1.5 meters per second. It lands 0.68 meters from the base of the table. So we know that 1.5 meters per second is our Vx, and we know that 0.68 meters is our Dx, okay? Drawing the picture helps a lot with filling in the chart. Again, we got 3 free givens here. We know the initial velocity in the y direction is 0 for any horizontal projectile. We know that the acceleration in the x direction is 0 for any projectile. We know the the acceleration in the y direction is 9.8 meters per second squared for any projectile. All right, so let's go through one by one. I think the first one is how long is in the air for? So I was looking for t. So I have a lot of stuff in the x column, so let's see if we can use it. Yeah, we can use the x column to solve for time. V equals d over t, or d equals VIT plus 1/2 AT squared, either one. We get t is 0.45 seconds. It's just a coincidence that it's the same value as the previous one. Now, to find let's see, how high the table is, that's our vertical distance. So we can use d equals VIT plus 1/2 AT squared. We know the initial velocity in the vertical direction is 0. We know the time now, it's 0.45. We know the acceleration is 9.8, and we get 1 meter. And last but not least, we can get the final vertical velocity, V final y. We use Vf equals Vi plus AT, get 4.4 meters per second. Again, we're only working in the y direction. Do not touch the left column. Or you can use Vs squared equals Vi squared plus 2AD. Again, only using the values in the right-hand column. You can't switch between the two columns. Since I need the V final in the y direction, I have to stay in the y column. All right. Now looking at these here, number 2, it says a bullet is fired horizontally. It lands 0.24 seconds later. It lands 300 meters away. How fast was it fired? How high was it fired from? So that's dy. You're looking for Vx, we're looking for dy, and we're looking for the final vertical velocity, V final, in the y direction. All right, so where to start? The first thing we can do is we can find the, let's see, what the first one's asking for is how fast was it fired? So looking for Vx, okay? So that's the first thing we're gonna do. So in the x direction, there's only one equation we can use, V equals d over t. So Vx is by unknown, d is 300 meters over 0.24 seconds. And I think this comes out to be something really big, like 1,250 meters per second. All right, so now we're looking for how high it was fired from. We're looking for dy. All right, so that's not changing right now. We'll go here. I'll change it to this color. So dy. So let's do d equals vit plus 1/2 at squared. You can try different equations, but this is the one that's going to work best. All right, so now we have d, we have vi is 0 times t, so that goes away, plus 1/2, 9.8, and then 0.24 squared. And then d should come out to be, let's see, yeah, 0.28. All right. Last but not least, we're looking for V final Y. So you have two options here. You can use, this is our second step, you can use VF equals VI plus AT, or VF squared equals VI squared plus 2AD. Use this one, VF equals VI plus 2AD, or excuse me, plus AT, rather. VF equals, so VI is going to be 0, A is going to be 9.8, T is going to be 0.24. All right, so VF comes out to be, I think that comes out to be 2.35 meters per second. So that's its vertical velocity as it reaches the floor. Number 3 I already worked out. Number 3 is actually a vertical projectile. So the whole x column is 0 because it's not moving left and right at all. All right. Now it looks like we're only given one given, the distance in the y direction, 56 meters. But don't forget, this is a vertical projectile question. We've done these before. It does have an initial velocity now. The initial velocity is only 0 in the y direction for horizontal projectiles. This is a vertical projectile. It is not 0. So in this case, that was one of our unknowns. Our final velocity in the vertical direction is 0 because at its max height, the velocity is 0. Our acceleration is going to be negative 9.8. It's negative because it's slowing down the ball as it goes upward. And we have our distance. So to find Vi, I can use Vf squared equals Vi squared plus 2AD, and I can get 33.1 meters per second. And for number 2, to get the time to the apex, it is Vf equals Vi plus AT, and I get 3.38 seconds. Now the hang time is simply multiplying the time to the apex by 2, because remember, time up equals time down. So if it takes 3.38 seconds to go up, it takes another 3.38 seconds to come back down for a total of 6.76. All right, number 4 here, bullets fired horizontally. So its horizontal velocity is 120 meters per second. All right, let me just draw a quick little picture here of what's going on. All right, so here's bullet, fired 120 meters per second. All right, and we have the t is equal to 0.34 seconds. Nothing else to really draw there. How far did the bullet go? So that's a dx. All right, so that was the first thing I did. Well, actually, let's just look at our givens real quick. So Vx is 120 meters per second. Acceleration is in the x direction is always 0. Acceleration in the y direction is always 9.8. Our initial velocity in the y direction is 0 again because this is a horizontal projectile, and our time is given to us 0.34 seconds. All right, so the first little bit here says, how far did the bullet go? So that's the distance in the x direction. So this is the only equation we can use in the x direction. V equals d over t. V is 120. T is 0.34. We get a distance of 40.8 meters. Next question is, how high was it fired from? So that's dy. So we can use our equation t equals vit plus 1/2 at squared. Our initial velocity in the y direction is 0, because we're looking for dy, so we have to use the y column. A is 9.8, and t is 0.34 squared. You get 0.566. And then take the final velocity in the y direction, use vf equals vi plus at. So this is our second step. This is our third step. So vf is our unknown, vi in the y direction, because we're looking for vf in the y direction. So vi in the y direction is 0. A in the y direction is 9.8. T is going to be 0.34. And that should come out to be 3.33 meters per second. All right. Now for this last one here, the distance in the y direction you should have gotten was 0.75 meters. The time for both trials was the same, 0.391 seconds. And you should have found that the distance in trial A was 0.98 meters. The distance in trial B was 1.96 meters. Okay. And so it's twice as far because it's going twice as fast. So how did we get dy? dy was real simple. I'm not going to spend a lot of time doing this one, but you know that the initial velocity in the y direction, v initial y, is 0. You could do a chart if you'd like. I would recommend it, but you don't have to. The acceleration in the y direction is going to be 9.8 meters per second squared. And the time is 0.391 seconds. So if you use the equation d equals VIT plus 1/2 AT squared, you should get that d is equal to 0.75 meters. That is dy. Okay, that's not dx. That's how high the table is. The time of flight for both of them are identical. The times of flight are identical. Okay. So for trials A and B, there was some confusion some people had about how to go about doing this. So here's trial A and here's trial B. Trial A has a time of 0.391 seconds. Trial B has a time of 0.391 seconds. Our velocity in the x direction for trial A is 2.5 meters per second. Our velocity in the x direction for trial B is 5 meters per second. Our acceleration in the x direction is 0 for both, so I'm not even going to draw that. And we're looking for dx in both the x, or excuse me, for trial A and B. So since we're working the x direction, we can only use one equation, v equals d over t. And you'll see if we use those equations up here, you get 0.98 meters for trial A and 1.96 meters for trial B. So since it's going twice as fast in the x direction for the same amount of time, it goes twice as far.